Welcome to this video about types in programming. In this video, the goal is to motivate and to explore the use of types in programming languages. And to this end, we will look at an example program written in different languages, in different programming languages, and we'll study how types are used in these different languages on the one example. The first language we look at is the C programming language, and here this is a tiny example program. It starts by declaring a floating point and a variable of type floating point, and defining this variable to be 3.14159. In the second step, we define a variable or declare a variable t of type character and assign it the value e. And the third step is to declare a variable z of type integer, and we assign it the value x plus t, where x and t are the floating point and the character that we have declared before. And then we print the result of this operation. And I want you to think about the following question. What is the output of this program? What do you think the output will be? I give you some time to think about it. You can also pause this video to have a bit more time. If you need some more time, you can even experiment and write down this program on your computer and compile it and see what the answer is. Okay, so let's look at what the output of this program is. The output is 3.14159 plus e equals 104. Are you surprised? I certainly was when I saw this. I want you to think about the following questions. What do you think of this program? Is it a useful program? And secondly, do you agree that the program should yield the output that it does yield? Do you think that this output here that I'm circling on the screen is useful output? Let's look at the very same program written in a different language, here in Python. This program starts as follows. We declare a variable x and assign it the value of 3.14159 as before, t another variable declared to be e, and the variable z gets the value x plus t. And then we print the output. What will the output of this program be? Again, I give you some time to think about this. You can also pause the video again and try this yourself on your own computer. Okay, let's look at the output of this program. It outputs actually an error message. It says in line 3, where we assign to z the result of x plus t, we get a type error. Python says we have an unsupported operand type for plus. We have float and string. So for Python, x here is a variable of type float, a floating point number, and e is a variable of type string. So it's a character array of length 1. And when we attempt to add, to use the operation plus on x on the one hand and t on the other hand, Python throws an error and refuses to compute this result. Let's look at this same program in a third programming language, here OCaml. Again, we declare x to be a floating point number, 3.14159, t to be a character, e, and y the sum of x and t. What do you think the output of this program will be? Again, I give you some time to think about this and maybe even to implement this on your own computer if you pause this video. Okay, here's the result when we try to compile this program or input it in an OCaml interpreter. We get an error in line number 3, which is the line where y is declared and defined. It says this expression has type character, so this refers to characters 19 to 20, which is about here where this t occurs. This expression has type character, but an expression was expected of type float. So what happens here is that this plus with the tiny dot behind it is a plus that operates on floating point numbers, and if we try to use it on a character, then OCaml will throw an error and will refuse to do so. Finally, we look at an approximation of the same program in Lean. We define x to be 3.14159, t to be the character e, and y to be the sum of the two. What do you think the output of this program will be? Give you some time. You can try it on your own computer. Okay, Lean will show the following error message. It will say there's a type mismatch at the application x plus t. It will complain that the term t has type character, but it is expected to have type natural numbers. Now here there's a weirdness in Lean where this number x is actually, it's not a floating point number or a real number, it's stored as a natural number. The reason for this is unknown to me, and it's not important for this example. What happens is that Lean looks at this plus here and refuses to add a character, the character e, to something because it is expecting a natural number instead of a character. So I would like to come back to the question of the first that we looked at after the first example, when we looked at the programming language C. Is this a useful program? And do you agree that the program written in these respective programming languages should yield the output that it does? The answers to these questions are, of course, somewhat objective. In my opinion, this program is not useful. It should never have been written. And I agree with how Python and OCaml and Lean react to this program, and I disagree with how the programming language C reacts to the program and accepts it and evaluates, even returns some output, the output 104 for the sum. So, to summarize what we should learn from this tiny introduction to typing in programming languages, types in programming restrict what we can do. They separate sense from nonsense. So types in programming languages should prevent us from writing nonsensical programs. Some programming languages enforce these restrictions, as we have seen, Python and OCaml and Lean, while others, like the C programming language, does not enforce these restrictions. Finally, I would like you to think on your own about the following questions. How does typing work in your favorite programming language? Does your compiler show an error message when it encounters an ill-typed program? And if so, what is that message? And secondly, what do you think? When are the restrictions imposed by typing most useful? That's it for this video. See you again soon.